theoretical probability. So first thing I want to identify is, what is an experiment? An experiment is a situation with several different possible outcomes. And within those outcomes, we call these our sample space. So for example, we have a dice, and this dice has 6 numbers on it. So our sample space would be 1, 2, 3, 4, 5, or 6 for a 6-sided dice. They also call it a die. We'll go through a few more here. So let's say we toss a coin. What would be the possible outcomes for tossing a coin one time? Well, you could either get a head or a tail. Now, let's pretend we toss 2 coins. What is a sample space? You could get 2 heads, 2 tails, a head and a tail, or a tail and a head. All right, how about rolling a dice one time? We talked about that. 1, 2, 3, 4, 5, 6. Picking a card. So if you think about your deck of cards, there are 52 different cards that could be given to you. All right, now let's say we roll 2 dice. The sample space gets pretty big. So we're going to show you that in a little bit, the different possible outcomes, 36 different possible outcomes. All right, let's move on to probability of an event. When you say the probability, try to find out what is the percentage or the fraction of that event occurring. So the fraction looks like this. The numerator is going to be how many times the possible outcome could happen, divided by the total possible outcomes, so your sample space. And our probability will occur somewhere between 0 and 1 as a decimal value. So the closer you get to 1, or 100%, the more likely it'll occur. The farther away from 1, closer to 0, which 0% means it doesn't happen, the less likely it'll occur. All right, so we're going to go ahead and give you a bag of marbles. And there are 3 marbles in the bag: a red marble, a blue marble, and a green marble. We're going to just do some simple probability here to kind of warm you up. First one, what is the probability of the following? So we're going to ask you, what is the probability of a red? So we look at our sample space. There are a total of 3 marbles. So remember, that's going to be in our denominator, our total of our sample space. Now we need to see how many times you could pick a red marble. There's only 1 red marble in our batch. So we have a 1 in 3 chance of getting a red marble. Now, sometimes we leave answers as fractions. Sometimes we convert it to a decimal. Sometimes we convert it to a percentage. So you'll see it 3 different ways. Fractions is usually the most common. All right, the next question is the probability that it not be green. So not be green would be a red or a blue. So you have a 2 out of 3 chance. The last one is, what is the probability of a purple? Well, if we look up in our marble set, there isn't any purple. So we have a 0 chance getting a purple marble. So 0 out of 3, 0%. Here's another simple probability problem. So we roll a dice once. So think about that dice. Its sample space is 1, 2, 3, 4, 5, and 6. To give you a total of 6 of them. What is the probability that if you roll the dice, you'll get an even? So let's count how many that are true. 2, 4, and 6. So there are 3 even numbers out of a total sample space of 6. We always want to reduce these fractions down, so 1/2. So you get 0.5 or 50%. Now, probability less than 6. So that would mean everything from 5 and below. So we have a 5 out of 6 chance of rolling something less than a 6. All right, now this is what I talked about before. What happens is now you're going to roll the dice twice. You have 2 dice here. You roll this one, and then you roll that one. And we want to see what this sample space looks like. Well, it gets a lot bigger. You could have 2 1s, a 1 and a 2, a 1 and a 3, a 1 and a 4, a 1 and a 5, etc. You start off with 2s, then 3s, then 4s, 5s, and 6s. So we have a total of 36 different possibilities. So this is our sample space. Now we're going to go ahead and answer some questions. What is the probability that the sum is 7? So we need to go up to our sample space and see which ones add to 7. So this one adds to 7. This one adds to 7. 7, 7, 7, and 7. So how many is that? There's 6 of them. So we have a 6 out of 36 chance, which remember we always want to reduce it down. So we have a 1 in 6 chance. Now, what is the probability that the sum is a 3? The sum is a 3. So we go back up to our sample space. Let's think about which ones are the sum of 3. Well, you could roll a 1 then a 2, or a 2 then a 1. So not as many possible outcomes, so our probability has now decreased. We have a 2 in 36 chance, or in reduced down form, a 1 in 18. All right, question 3, the probability that it's not 3. So we think about, we had only 2 that were a sum of 3, so we're going to get to this later of this complement. So you think about, there are then 34 different choices left out of 36. If we looked up here, if those were a sum of 3. So we reduce that down to 17/18. Sum is less than 10. So we go up and find anything that is less than 10. We count them up. So you'll notice all of these are less than 10. All of these are less than 10. All of these are less than 10. And now when we get to the next row, this one's still good. Oh, less than 10. There. All right, now we add them up. Or we can think about the ones that are 10 or higher. So this one's 10 or higher, 10 or higher, 10 or higher. And we subtract out. So it looks like we have 6 of them. 6 minus 36 is 30 green ones. So a 5 out of 6 chance. Question 5, what is the probability the sum will be 1? Well, if we look up, that would not ever be possible. It's the smallest you could ever get would be a sum of 2. So you have a 0% chance of getting a sum of 0, a sum of 1. Last one, probability is a sum less than 13. Well, that's every single one. If we go up here, the highest you can get is a 12, a 6 and a 6. So that means you have a 100% chance of getting a sum of less than 13.